You know the fundamentals now. You understand how learning works. You've built the foundation. But there's another layer, a set of neural leverage points that most people never discover. Small interventions that produce disproportionate results. Tactical enhancers that, when applied strategically, can accelerate learning in ways that seem almost unfair. These aren't the main event. These are the multipliers, the catalysts, the things that take your existing practice and amplify its effectiveness. And most people ignore them because they seem too simple, too subtle, too unconventional to matter. But they do matter, because your brain responds to signals you're not consciously aware of. And when you learn to manipulate those signals, you gain access to neural leverage. Let's explore the accelerators hiding in plain sight. Rhythm accelerates procedural learning. Your brain has internal timing circuits, oscillations that coordinate neural activity. And when you introduce external rhythm, when you practice to a beat, to a pulse, to a regular temporal structure, you entrain those circuits. You synchronize them. This synchronization does something remarkable. It accelerates procedural learning. Skills that involve sequences, movements, patterns. They get encoded faster when practiced rhythmically. Musicians know this instinctively. They practice with a metronome. The steady beat provides a temporal scaffold. The movements lock into the rhythm, and the rhythm helps the brain chunk the sequences, organize the timing, build the motor program. But this applies beyond music. Any skill with a temporal component benefits from rhythm. Typing, dancing, sports movements, even memorizing sequences of information. When you add rhythm, when you create a regular pulse, your brain's timing circuits engage. The learning becomes more structured, more efficient, more automatic. So if you're learning a procedural skill, introduce rhythm, practice to a beat. Even if the skill doesn't naturally have rhythm, impose one. Count, clap, use a metronome. Give your brain the temporal structure it craves, because rhythm accelerates procedural learning. It's neural leverage you can add with almost no effort. Bilateral movement increases integration. Most skills are practiced unilaterally. You use your dominant hand, your stronger side, your preferred limb, and that's fine for building skill on that side, but it leaves potential on the table. When you practice bilaterally, when you use both sides of your body, something interesting happens in your brain. The two hemispheres have to communicate more intensely. Information crosses the corpus callosum, the bridge between hemispheres, and this cross-hemisphere communication increases neural integration. The result: deeper learning, more robust skill, better transfer. When both hemispheres are engaged, the skill becomes encoded more symmetrically, more completely. It's not just in one motor map, it's distributed across both. This is why ambidextrous practice is so valuable. Not because you need to be able to do everything with both hands, but because practicing with both hands builds more complete neural representations. Even if your skill is naturally one-sided, find ways to involve both sides. Switch hands periodically. Use non-dominant limbs for variations. Force bilateral engagement. Your brain will build richer, more integrated circuits, and those circuits will support better performance even when you return to using just your dominant side. Bilateral movement increases integration. It's a simple way to build deeper, more robust skill without changing what you're practicing, just how you're practicing it. Mirror neurons amplify imitation. Your brain has a remarkable system: mirror neurons. These are neurons that fire both when you perform an action and when you watch someone else perform that action. They allow you to internally simulate what you're observing. This is the neurological basis of imitation, and it's incredibly powerful for learning. When you watch an expert perform, your mirror neurons are firing as if you were performing. You're getting a neural rehearsal just from observation. But here's the key. Mirror neurons work best when you watch with intent to imitate. Passive watching activates them weakly. Active watching, where you're mentally rehearsing, imagining yourself doing what you're seeing activates them strongly. So when you watch tutorials, demonstrations, expert performances, don't just watch. Watch with your body, feel yourself doing it. Imagine the movements. Let your mirror neurons fire fully. You're not just observing, you're pre-practicing. And after watching, immediately try it yourself. The mirror neuron activation primes your motor system. The actual execution will be smoother because your brain has already rehearsed it vicariously. Mirror neurons amplify imitation. Use them deliberately. Watch experts not passively but actively, with full engagement of your motor imagination. And you'll learn faster from observation than you thought possible. Music modulates learning state. Music isn't just background noise. It's a powerful modulator of brain state. Different types of music push your nervous system in different directions, and you can use this to optimize learning. Upbeat music with a strong rhythm increases arousal. It activates your sympathetic nervous system. Heart rate goes up. Alertness increases. This is useful for skills that require energy, speed, intensity, physical practice, high-energy performance. But for tasks that require deep focus, calm concentration, analytical thinking, upbeat music is counterproductive. It's too activating. Instead, you want ambient music, minimal lyrics, slow tempo. This supports sustained attention without overstimulation. And for memory consolidation, for studying conceptual material, some research suggests that certain types of music, particularly Baroque music with a tempo around 60 beats per minute, can enhance encoding. The rhythm may entrain brain waves in a way that supports learning. The point is, music is a tool, different music for different tasks. Don't just put on whatever you like. Match the music to the cognitive state you need. Use it strategically to modulate arousal, focus, and encoding. Music modulates learning state. Choose it deliberately, and you add another layer of optimization to your practice environment. Cold exposure heightens alertness. Your nervous system responds to temperature. Cold is a stressor. An acute cold exposure, brief and controlled, triggers a cascade of neurochemical changes. Norepinephrine spikes, dopamine increases. Your brain shifts into a state of heightened alertness and focus. Blood flow increases, metabolic rate rises. You become more awake, more aware, more capable of intense effort. This is why a cold shower before practice can be so effective. Not for the physical benefits, though those exist, but for the mental state it creates. You're shocking your system into a high alert mode, and in that mode, learning happens more efficiently. The cold doesn't need to be extreme. Even a brief exposure, 30 seconds to 2 minutes, is enough to trigger the response. And the heightened state lasts for a period afterward, giving you a window of enhanced focus and energy. Cold exposure also builds mental resilience. It trains your nervous system to stay calm under discomfort. And that skill, the ability to maintain focus despite discomfort, transfers to other domains, including the discomfort of difficult practice. So consider using cold strategically. Before a challenging practice session, expose yourself to cold water, not to punish yourself but to prime your nervous system, because cold exposure heightens alertness, and alertness is rocket fuel for learning. Visual sparsity increases salience. Your visual system is constantly filtering. Most of what you see gets ignored. Your brain only pays attention to what stands out, what's salient, what's different from the background. When your practice environment is cluttered, when there's visual noise everywhere, everything competes for attention. Nothing stands out. Your focus scatters. You're processing irrelevant information, and it's draining your cognitive resources. But when your environment is visually sparse, when there's nothing to see except what matters, salience increases. The relevant information dominates. Your attention locks on. There's no competition, no distraction, no drain. This is why minimalist workspaces are so effective. Not because they look good, but because they reduce cognitive load. Your brain doesn't have to filter out clutter. Everything visible is relevant. Focus becomes effortless. So when you design your practice space, remove visual noise, clear surfaces, minimal decoration, nothing irrelevant in your line of sight. Create an environment where the only thing to look at is what you're working on. Visual sparsity increases salience. It makes the relevant information pop. And when information is salient, your brain encodes it more deeply, more efficiently, with less wasted effort. Temporal contrast sharpens encoding. Your brain notices change. It notices contrast. When something stays the same, your attention fades. But when something shifts, your brain wakes up, and you can use this to sharpen encoding. Temporal contrast means varying the pace, the intensity, the structure of your practice within a session. Don't just grind at the same level for the entire time. Instead, alternate. Go hard, then easy. Fast, then slow. Intense focus, then relaxed exploration. These shifts create contrast, and contrast creates attention spikes. Every time the practice shifts, your brain notices. Engagement refreshes. Encoding sharpens. This is also why interleaving works so well. It's not just about mixing content. It's about creating contrast. When you switch from one type of problem to another, there's a temporal shift. Your brain has to adjust, and that adjustment process enhances learning. So build contrast into your practice. Don't let it become monotonous. Vary the rhythm, vary the difficulty, vary the task. Keep your brain on its toes, because temporal contrast sharpens encoding. It prevents habituation. It keeps learning active instead of letting it fade into background noise. Novel reward schedules sustain engagement. Predictable rewards lose their power. When you know exactly when the reward is coming, dopamine stops spiking. The anticipation disappears. Motivation flattens. But novel reward schedules, where rewards come at unpredictable intervals, sustain engagement. This is the principle behind slot machines. You don't know when the next win will come, so dopamine stays elevated. You keep playing. You can use this in learning. Instead of rewarding yourself the same way every session, vary it. Sometimes after 10 minutes of practice, sometimes after 30, sometimes after hitting a specific milestone, sometimes randomly. The unpredictability keeps your dopamine system engaged. You don't habituate. You stay motivated because there's always the chance that this might be the moment you get the reward. This works with internal rewards too. Sometimes you'll have a breakthrough, sometimes you won't. The variability, the not knowing when the next moment of insight will hit, keeps you coming back. It sustains curiosity. So don't make everything predictable. Introduce variability into your reward structure. Keep your brain guessing. Because novel reward schedules sustain engagement. They prevent the motivational plateau that kills long-term practice. Social evaluation boosts performance networks. You perform differently when someone is watching. Your brain knows it's being evaluated, and that knowledge activates performance networks. Arousal increases, focus sharpens, effort intensifies. This is called social facilitation. The presence of others, particularly when they're evaluating you, enhances performance on well-learned tasks. You rise to the occasion. Your nervous system shifts into performance mode. You can use this deliberately. Practice in front of someone. Get a coach. Join a group. Create accountability with peers. Even recording yourself, knowing you might show it to someone later, can activate this effect. The social element adds stakes. It makes practice feel more real, more consequential. And that feeling drives higher quality effort. You're not just going through the motions. You're performing. And performance-level effort builds skill faster than casual practice. There's a caveat. On novel, unlearned tasks, social evaluation can actually impair performance because the pressure creates anxiety. So use this accelerator strategically. Once you have basic competence, introduce social evaluation to push yourself harder. But in the early stages, practice privately to avoid performance anxiety. Social evaluation boosts performance networks. Use the presence of others to elevate your intensity, and you'll build skill faster than practicing alone. Environment ownership increases persistence. When you control your environment, when it's yours, when you've designed it and shaped it to support your practice, something psychological shifts. You feel ownership, and ownership creates commitment. This is why having a dedicated practice space is so powerful. It's not just about convenience, it's about identity. This is your space, your domain, the place where you become who you want to be. And that sense of ownership makes you want to show up. It makes you want to protect and honor that space by using it. Contrast this with practicing in shared spaces, generic locations, places you don't control. There's no ownership, no attachment. It's easier to skip, easier to abandon. So claim a space, even if it's small, even if it's just a corner, make it yours, arrange it, personalize it. Let it become the physical representation of your commitment. And that ownership will pull you back, day after day, even when motivation is low. Environment ownership increases persistence. It transforms practice from something you do somewhere into something that happens in your space, your territory, your sacred ground. And that transformation makes consistency effortless. These are the accelerators, the neural leverage points most people never discover. Rhythm, bilateral movement, mirror neurons, music, cold exposure, visual sparsity, temporal contrast, novel rewards, social evaluation, environment ownership. None of them are the main thing, but each one is a multiplier, a small intervention that amplifies everything else you're doing. And when you stack them, when you use several together, the cumulative effect is significant. You're not just practicing anymore. You're practicing in an optimized state, in an optimized environment with optimized methods. You're pulling every lever, using every tool, extracting every bit of neural leverage available. This is what separates good learners from exceptional learners. Not just knowing the fundamentals, but knowing the accelerators, the tactical enhancers, the subtle manipulations that squeeze more learning out of every minute of practice. You now have access to all of them. The question is, which ones will you use?